Hello, and thank you for joining us for this second part of our three-part series on telco telemetry evolution. During part one, we took a quick look at some basic definitions of telemetry and how telemetry collection systems, such as ocular IP, need to deal with interval alignments as well as historical data to deliver the desired functionality. We also briefly touched on ocular IP's capability to collect telemetry using a multitude of protocols. Today, we will continue by looking at the telemetry collection methods that are commonly used in the market and how the end usage of telemetry data has impacted these methods and the collection frequency. There are two main collection methods available for retrieving telemetry data: pull and push. With the pull methodology, it is the telemetry collector that asks the network elements for data. The collector is centrally configured with a list of network elements to collect from, as well as the list of metrics to retrieve. The main challenge here is that the pull frequency and phase of the collector may not align with the network element's metrics interval. Care must be taken to ensure that the data model of the network element is sufficiently understood to collect the correct metrics at the correct time. This method also requires careful consideration to ensure that the network elements do not have to deal with more volume than they are engineered to handle. The second method is the push method, which can be subdivided into dial-out and dial-in subscriptions. In the dial-out subscription model, it is up to the network element to transmit telemetry to the collector. It uses a distributed telemetry collection configuration, where each network element is configured with what to send, at what frequency to send it, and to which collector to send it to. This can be cumbersome when telemetry configurations need to change, as the change needs to be made on each network element. The main advantage of the method is that since it is up to the network elements to push, they can push only completed intervals. This eliminates the problem of phase and frequency alignment faced by the pull method. The dial-in subscription model combines the advantages of the pull and push dial-out methods in that the network elements still transmit the telemetry to the collector, but they receive the list of metrics to transmit from the collector. This allows for a centralized configuration of telemetry collection and the network element push of completed intervals. If you look at the popular push and pull protocols today, we will find three main protocols. The first one is SNMP. SNMP has been around for a long time. Its simplicity and MIB-based data model have made it the most popular collection method on the market today. MIBs are standardized and shared, allowing multi-vendor collector implementations. Likewise, the MIB language is well defined, such that even proprietary MIBs can often be supported by simple configuration. This protocol is used by popular collector products, such as our very own Ocular IP. This protocol does have some scalability limits, however, and care must be taken to ensure that the polling collects the correct intervals at the correct time. Also in the poll category are web service or HTTP polls. This method is very similar to SNMP polls, except that this is going over HTTP or HTTPS transport. The type of data that is retrieved here is typically XML or JSON documents. There's actually very little standardization in the data models, and that makes most implementations proprietary. Ocular IP uses this method for data collection from Nokia platforms. The last protocol is a CSV file exchange. In this method, the network elements generate historical metrics into CSV formatted files at regular intervals. The file contents are very proprietary, making these implementations vendor specific. The CSV files are saved on the network element and can then be pushed to a collector via SFTP or retrieved by the collector in a pull model. The pull model is seldom used. The CSV push method has been much more popular and is supported by Ocular IP for several technology integrations. The frequency of the data collections has been greatly influenced by how the telco telemetry data is used. It was originally used primarily for reports and trending. Typical uses would be to produce monthly service level agreement compliant reports or bandwidth usage reports that could be looked at for long-term capacity planning of network growth. In these cases, the data collection could be done daily, and the data was very much used in an offline processing model. As telemetry collection frequency increased, we started to see alerts based on telemetry data. Collectors would define thresholds where alerts would be raised if certain conditions were exceeded. Examples here include service level objective violations, environmental issues that could cause outages, or congestion issues that are impacting services. With this type of usage, data collection frequency increased to 15 minutes and even 5-minute intervals, making it very much a near real-time processing function. More recently, with the advent of technologies such as SDN and NFV, Telemetry data has been promoted as a key enabler for closed-loop automation. This type of automation could be used to make adjustments to traffic policer configurations or to trigger the instantiation of virtual network functions to address transient network load. This requires real-time processing and real-time telemetry. Telemetry streaming has been introduced to fill that need. Please join us for part 3, Telemetry Streaming, where we will discuss the latest developments in this area. Thank you for joining, and if you need any additional information, please contact us at learnmore@ocularip.com.